All right, let's go on to the next one on the sheet. And so it says to find the electric field and potential. So these are the net electric field and the net electric potential at the center of a square, side length 2 centimeters, with charges of +9 microcoulombs at each corner. Okay. So let's go in and let me draw that one out. So there's my square. It's kind of square-ish. We're supposed to find the field and the potential at our point, which is at the center. So this is the location of interest. And these were all 9 microcoulombs. So I'm going to give them names, you know, the 1, 2, 3, 4 names, because that helps me track, you know, which one we're looking at. Okay. And they said that this was our 2 centimeters. Okay. So what we're going to need is we're going to need the distance from the charge to the point. Okay. And so if we, you know, divide this in half, and divide this in half, then this would be 1 centimeter here. And then this would be 1 centimeter here. And we could get a nice, you know, right triangle. Okay. And so then we'll want to calculate this R1 value. So this is going to be 1 centimeter squared plus 1 centimeter squared. I guess I'll just leave it in centimeters for the time being. And so then this is the, you know, square root of 2, right? So that's 1.414. But now the thing that we need to see is that it's a square, right? So then the distance from charge 2 to that same point, and the distance from charge 3 to that point, and the distance from charge 4 to that point, these are all what? They're all the same. Yep. So they're all the same distance and they're all the same charge. So when we go to find the magnitude of the field, so the E1 magnitude is K absolute value of Q1 over R R1 squared. So our 8.99, 10 to the 9th. And then absolute value charge 1, this is 9, but then it's micro, which is 10 to the minus 6. And then we'll need to, I'll do the 1.414. Centi is 10 to the minus 2. I'll square it. I'll do it that way. And so we can get our magnitude here, but again, the K is a constant. All the Q's are the same. All the R's are the same. And so all our magnitudes are going to be the same. What is the magnitude? So we'll just calculate that. 4.05, 10 to the 8. Thank you. And as we mentioned, that, essentially by symmetry, these are all going to have the same magnitude. Now, when we go to find our directions, because these are vector quantities, remember we're going to start at point P, and since charge 1 is positive, it's going to go, out away. So starting at P and going away means that my E1 as a vector goes towards Q3, away from Q1. And then the E2, again, goes away from charge 2. And then E3 goes away from charge 3. And then E4 goes away from charge 4. And then you're like, oh, good grief, look at all those components. Except that if you, well, I guess my diagram's not so great, is it? If we turn it, they should cancel by pairs. And so really what will happen is that these are equal in magnitude, opposite in direction, so they cancel. These are equal and opposite in direction, they should cancel. And so essentially what we get for our answer is that the net electric field at that center of the square is 0. And essentially it's that way by symmetry. It was kind of nice we didn't need to find x and y components, put all the x's together, put all the y's together. You'd still get 0 if you didn't see that it was gonna, cancel by pairs. But yeah. All right. Well, then what about the potential? And so with our potential, this is going to be K times Q1 over R1. But again, all the Q's are the same, all the R's are the same type of things. So let's evaluate this. So this is our 8.99 times 10 to the 9th plus 9.0 micro is 10 to the minus 6. And then this is going to be our 0.01414. Don't square it. Okay, so I moved it into meters. Don't square it. And so what do we get for the value for V1? So really it's this calculation here, but without the square. (5.72 10 to the 6). Again, this is the same as V2, same as V3, same as V4. So by symmetry, what are we going to get here? Well, the idea is that we're going to add these up, right? But they're all the same. So it's quadruple this result. It's not 0 because, again, these are scalars, not vectors. There's no directions. 2.288. Yeah, 10 to the 7th. Oh,